That last video was a short one. This one will probably be a little bit longer. So I wanted to look at some of these word problems. We looked at the substitution problems. Notice really quick to just jump to question 8 for a minute. Notice in question 8, it's already solved. X is already solved for. And so what's nice is you can just substitute that right into X in the other equation. So in the earlier problem, we had to actually solve for the variable, but yeah, sometimes it'll just give it to you just like number 8. But let's go ahead and look at number 7. So number 7 is a systems of equations problem, but we need to set up the two equations ourselves. And to me, that can be the hardest part. So we have a store owner that wants to develop a new snack mix by mixing chocolate and trail mix. How many pounds of chocolate costing $20.20 per pound, in fact, let's underline that whole per pound, should be mixed with trail mix costing $3.30 per pound to create a 24-pound mixture worth $12.45 per pound, round to the nearest pound. So basically what we have are two different kinds. We have a chocolate and a trail mix. So I'm just going to have C for chocolate. So basically how many pounds of chocolate, and T for the trail mix. So that way when we get to the end, we can see what our variables are going to stand for. So we know total, it's going to be a 24-pound mixture. So first that's what I'm going to do. I know I'm going to have so many pounds of chocolate plus so many pounds of trail mix, and that's going to give me the total 24 pounds. This is what I think of as the quantity equation, just kind of our basic equation. And a lot of these problems will have something like this where you're just having kind of a simple equation to start. Just so many pounds of chocolate, add on the so many pounds of trail mix, and we know that's going to give us our total. Now, we're going to do basically the same equation, but we're going to add in the dollars. So we know that chocolate is $20.20 per pound. So I'm going to just write $20.20 times however many pounds of chocolate we have. We need to add that to $3.30 times however many pounds of trail mix we have. And that will give us $12.45 times our total 24 pounds. Okay, so we're going to basically figure out the cost. So this will be the total cost, $12.45 times the 24 pounds. And to create that, we need to do $3.30 times however much trail mix, and then $20.20 times however much chocolate. Okay, I'm going to go ahead and simplify this problem a little bit. First of all, since the zeros are second, we don't need to have them anymore while we're solving this equation. So I'm just going to go ahead and write 20.2c plus 3.3t equals, and that's 298.8. And just because I think it'll make this equation a little bit easier, let's go ahead and multiply everything by 10, just so we can move all of the decimal places over 1. So we'll multiply every single term by 10, and we'll get 202c plus 33t equals 2,988. And then we still have that original equation, c plus t equals 24. So we can solve this either the elimination method or the substitution method. It really doesn't matter which. I think this time let's do substitution. So let's go ahead, I'm just going to minus the t. We get those cancels, so I'm left with c equals 24 minus t. So now at this point, we need to substitute this in, 24 minus t, in place of c in the other equation. So we'll have 202, and then c, then I'm going to go ahead and write the rest, plus 33t equals 2,988. We'll put the 24 minus t in. Let's go ahead and distribute. So 202 times 24, we'll get 4,000 848 minus 202t plus 33t equals 2,988. So at this point, we're just kind of simplifying. We're just trying to get like terms on the same side. So let's go ahead and combine our negative 202 and our 33. So we'll get, we still have 4,848 minus 169t equals 2,988. We'll minus this 4,848 from each side. We get 1860. So negative 169t equals 1860. We'll divide. Oh, I almost made a mistake. Hopefully as you're watching you caught it. It should be a negative number because the 4,848 is bigger than the 2,988. Now, if that wasn't negative when I divided, my final answer would have been negative. And that should also give a red flag. If your final answer on these word problems is negative, you should think, I did something wrong, because we can't have a negative number of pounds of trail mix. Okay, so that's actually a great way to check yourself. You should be getting a positive answer for sure. Okay, so we divide that. Okay, now that gives us 11.006. Oops. Now that gives me a little bit of a red flag because it's not a whole number, and oftentimes on these word problems it will. However, I went and looked back at the original problem. Notice it says round to the nearest pound. So that makes me think, I think let's look through the work. I think it looks good. And so we're going to say, okay, that rounded to the nearest pound, we're going to be at 11 pounds. So 11 pounds of trail mix. And so chocolate, if we knew together, it was 24 pounds. We're going to have 13 pounds of chocolate. Oops, sorry about that. 13 pounds of chocolate. Now what you can do in this is you can always check and see, does that sound about right? Would we need more chocolate? Yeah, we would. To get up to that 1245, we would need a little bit more chocolate. But I think that sounds about right. We got positive answers. But the hardest part on these is just setting up the equation, so make sure you understand that part especially. Okay, we're going to look at one more word problem here. We've got a carnival. $5 for adults, $5 for children, $10 for adults. Let's go ahead and underline those. One evening, 774 tickets were sold. Total price was $5,160. How many children and how many adults attended? So first thing I'm going to do is kind of similar to the last one. I'm going to use C for children and A for adults so that when we get to the end, it's really easy to know what they stand for. Now, I know total they sold 774 tickets. So that means if I add children's tickets and the adult tickets together, I'm going to get 774 tickets total. Now, if I get $5 for every child's ticket and add it to the $10 I get for every adult ticket, that will give me the total amount for $5,160. So you can see this problem is a little bit different than the last one because we didn't have to multiply. We were just given that 5,160. So it's good to make sure you understand both of those different types of problems, when to multiply and why. So in this case, let's go ahead and solve this using the addition or the elimination method. So I'm going to get the C's to be the same but opposite. So I'm going to go ahead and multiply everything here by -5. Okay, so I will get -5C minus 5A equals, let's multiply 774 times negative 5. We get negative 3,870. So I'm just going to cross that equation out so I know I'm done with it. Now I'm going to add these two equations together. These two will cancel, which is why we're doing it this way. It's so great. 10a minus 5a, we get 5a, and then we want to do 5,160 minus 3,870, and we're going to get 1,290. Let's divide by 5, and we'll find out how many adult tickets we get, which is 258. Okay, so if we have 774 tickets sold, makes sense that we could have 258 adult tickets. Oops. Okay, now let's go figure out how many children's tickets. So since we knew 774 were sold, we can subtract 258 from that 774, and we get 516 children's tickets. Now I think that seems pretty reasonable, that there would be more adults than children. That can happen, right? I think we got positive answers. It seems in the right ballpark. And so I would say, yeah, feel pretty confident on that problem. I would encourage you to do that when you're doing these. Like, okay, does this seem right? Are my answers positive? Do they seem reasonable? And then you can move on. Okay, the last problem we're going to look at here is number 12. We need to decide if this -3, -5 is a solution of the system. How do you decide if it's a solution? What does that even mean? Well, what it means is if I graph these lines, this is not the real graphs, I'm just drawing examples. If I graph these lines, we're wondering, or actually I should have done -3, -5, huh? We'll do it like this. We're wondering if when we draw these lines, if this is the point that they cross at, this -3, -5, right down here. Okay, now we could graph them to find out. That's one way to do it. The way I would recommend doing it is using algebra. And so what you can do is you can substitute this point into each of these equations and make sure it comes out as true. So first we would do 3 times -3 plus 2 times -5 equals -19. And solve that out and see if it comes out true. If it comes out false, we're done. We can just say false. But if it comes out true, we still have to check this other equation. And then we plug it in that second one. So -5 for y equals -6 times -3 minus 23. Oops, we didn't need that parenthesis. And then we solve this one and make sure this one comes out as true. So if this one comes out as true and this one comes out as true, they both have to come out true, then we know that this -3, -5 would be a solution for the system. Okay, that's the end of this video.